IMI-eTOX is about trying to get the data from the pharma companies on their drugs, tox packages. So when you want to go for registration for a compound, a drug, if you are going for registration, you will have to do several studies in animals. All these studies are just PDF files at the end that are sitting in the companies at the FDA, and there is not so much mining ongoing. So the idea of eTOX is to get this data out. High quality data, it's under good laboratory practices and a lot of regulation. Trust me, it's quite standardized. There is a strong diversity there. We have to do many studies, ranging from the acute dose to very long, for the lifelong carcinogenicity things. So there is really not touching anything. For people online, it's not me. So there is really a lot of diversity also. And the big deal for us is that the chemical space is the one we are looking at. It's the druggable space. So, two goals. The first one is to collect the data, extract the data, be able to use them. It's not that easy actually, it's what I'm going to discuss now. And the second one is to do predictive systems, and I'm not going to tackle that one today actually. So, lesson one. Getting data takes time, a lot of time actually. So if you look at the numbers here, so the green one is the one you want to look at. It's the number of reports that made it into our database, that are final and that can be seen by modelers and biologists. So the consortium did start in 2010. If you look at the curve, there is nothing ongoing until 2012. It took us 2 years to get the things to run. And you can imagine that the consortium started before that actually. So we are aware, we started IP discussions before signing up for the consortium. So basically years of discussion just to get the data out. The good news is that we made it there, and, which is good for both the consortium but also for transparency in general. But it took a lot of time. Lesson 2, bad news. Getting cleaner data is better, and it takes really a lot of time actually. So when we got the first data, we just had a look in there. So what we are doing actually is to get the data from the reports. That means that we have curators going to the reports, getting the data out. And the big deal is that we do not have proper code lists for that. So we are taking the verbatim. Because the code lists were not ready, and well, there are a lot of efforts, we'll discuss that later probably, going on that. And also because we wanted to have read the verbatim. It's written by toxicologists, and toxicologists, like the MDs, do like to be very precise and to tell things with long sentences that are convoluted. So it's like dealing with electronic health records. If you're exposed to that, it's the same kind of things. It's really quite hard to get the right data out. So I'm in charge of the work package 2, which is up there, ontologies, text mining, and visualization. And our goal is to get from the verbatim terms that you extract to something that we can use. Easy, of course, I would say. So, why not using code lists, by the way? So the truth is that it's not mature in toxicology. It's coming. So there was some efforts from OpenTox. We just heard that in the first talk. There is also an effort from the FDA to get normalized data now. So it's part of CDISC. It's the same part of the SDTM of CDISC. So we have code lists coming now. But to be honest, that's not mature, and it was certainly not there at all in 2010. The other thing is that the complexity is quite large. So when you look at the tox studies, you will have all the things from the protocol. The metadata, basically, it's a big deal actually. You want to know what is the species, strain, the age, and things like that. But then you will have the food and water consumption, the in-life observation during the study. You will take clinical pathology, so lab values basically, and you will get the exposure, Cmax, AUC, all the DMPK stuff, body weight, cause of death, and then once you're at the end, you will go for the histopathology. So that's really a lot of things. And then on top of that, you have specific biomarkers, on the safety farm, ECGs, things like that. It's really a lot of things that you can find there. But at the end, the gold standard, if you have to ask to a toxicologist, what you want to go after is the histopathology. So at the end of the study, you slice the animal, and you look at the different slices, and you look at what is in there. That's really what is used as the very basic thing for pathology. And there is things running since years, but there is no code list. That's the big deal. So in-end is the main thing, run by the toxicologist and the pathologist, and it's a worldwide thing, and it's still ongoing. So it's really a tricky situation where we have to collect data, but the code lists are not there. And there are ontologies also, but I don't even know. I don't even want to speak on that slide. So look at what is in there. Oh, slides are not okay. So I just went after the glucose level. Glucose is glucose, right? So you have all the company acronyms. You have somebody calling it sugar. Is sugar glucose? Well, you have to know, so you have to ask. You have the things about the matrix, where the glucose was taken, the detection methods, the distinct measurements that you can do. You have the things from the protocol, so the animal was fasting. You have OCR also running, so that one is a good one, glucose. So we have OCR, automatic character recognition, running before there is the people annotating the things. So we have really a lot of diversity in there. So that's the type of challenge we have actually. So verbatim term curation is really essential. So you are going to have the verbatim, you want to map them to code lists and ontologies that exist. It's really a big deal and it takes a lot of time. It's where we spend most of our time in the work of GIF2, to be honest. The thing we have seen there, and I think you have seen that in other activities, because if you want to model, you want to do that. You want to clean your data. And the big deal we have with that kind of things is that you need experts actually to do that. You can't just take somebody for the summer and get the things done. It doesn't work. Because the person will not be an expert and you have no way to check the quality at the end. Even if you do some QC for part of it, it doesn't work. So that's where you have to have experts. And the problem is that, well, you do not really have user interfaces that are easy for them. So we created one. That's why I want to mention it there. So that's two things. The first thing is a source of truth for eTOX. That's where we have all the ontologies and code list. When you want to know what you can use for a search, you can get there actually. It's a central place to browse the things. It's also actually full of web services to plug to other systems and to extract data actually. The second part is really the part where you can edit. So it's connected directly to our databases, to the input. It's getting us the verbatims, telling us, hey, we have new terms to map. And the people who are assigned to these domains are going to map the things to the code list and ontologies. Okay. So at the end of the day, you really need something like that. It doesn't exist. So far, I think it's the first one I've seen which is really easy to use for experts. And I wanted to point that today because, well, it's open source actually now. So we did send out last year, to the public domain. Why putting it in public domain? Well, first because there is really a need, and we think it can be reused. It's really generic. Also because, well, we hope that people will use it. You never know. And to be honest, well, putting something in the public domain is a commitment. That means that you will probably have people using it. You will most probably do not have any help to build the thing, and you have to maintain it. So it's really a commitment that we made. So eTOX, but also Novartis, who is behind that software actually. And if you're interested to discuss that one, actually, it's really it's open to anybody to come. Okay, so then the question is, how hard is it actually? You said there are a lot of verbatim terms that you extract. What's the landscape there? So the landscape is a lot actually. 18 million lines of data, more than 100,000 distinct terms used in the data. I just discussed there the things that we are actually curating. There are a lot more in the database, but it's just the fields that we are curating. And the very bad news for us are the curves that are there. So here, on the bottom of the purple thing, you have the number of companies. So we have 13 pharma companies who submitted things. It's okay. Number of structures, compounds, is in blue. And while that's going up, it's okay. Number of studies is in red, so you have more than one study per compound, well, as expected. It's following the same trend. Everything is nice. And then the green one is the number of distinct verbatim terms that we have. And that one is no fun actually. So it's a logarithmic scale, as you can see. And we expected it to become flat with time. It did not happen. So that's no fun at all. So 2 years ago I was really saying, okay, we see a plateau coming. And it was true actually because, well, at that time there was an inflection. But, well, actually at the end it's still growing a lot. And that means that even if you are covering the same partners, so we have the report from the same people coming since a long time, the history of talks and the diversity of things is making it so complex that we still have a lot of verbatim terms coming. And we had just a burst end of last year. It's really it's a big deal for us. It takes a lot of time. So don't take it for granted, and that with 7,000 reports in there, you would already have seen all the terms. It's not what is happening. And that's wow. So it's a commitment. So let's assume that you are getting there. So actually, I will even claim today that we made it there, meaning that we are covering verbatim terms for 100% of them for most of the categories, except few of them. So in-life observation on histopathology that we can discuss later if somebody is interested, where we are not at completion because it's just too hard. We will not make it there. But well, if you have data that are clean, you can start to raise questions. So the most basic one. What is the most frequent observation in anatomic pathology, histopathology? What do you think is the thing that we see first when we look at the highest incidence of the terms? That's interactive, that's for you. Usually a liver on that question. Actually, if you look at the most frequent observation, there are many of them, but basically it's no abnormality is detected. That's what you see everywhere. So basically in a tox study, you do not harm all the animals. Many of them are just okay. When you raise the doses, of course, we go to a level where you have to see where the effects are starting, and there are some effects, but most of them are okay. So that's the first thing you see. And then the second question, of course, is what is the most frequent adverse finding? So now things that are really toxicology or not normal findings. Can you guess what is the organ which is the most common there? At the organ level? Liver. Okay, what is the second one? Kidney. Okay, great. So liver is the main one, kidney, well, you will recognize here the tox study basically. So it's the main tox that we observe. It's also a bias on where we look at actually. You have to know also that in tox studies, we do not look at all the organs. So it's really, well, it's coherent with what we expected there. And of course, depending on what you get in tox, well, when you have liver issues, it's not so bad. When you have things touching to the heart or things like that, you are, wow. Ooh. So depending on where you are, the compound will not have the same life later on. Okay, so what can we do? Hackathons, of course. So we did the first one last year in May in Barcelona. We'll have the second one actually next week in Barcelona again. The first one gave some results. I'm not going to details here, but to give details. But well, there was, in terms of models, nothing really totally new, I would say. But there was a breakthrough in text mining, because we are doing text mining also activities related to the reports, but also already the use of the verbatim on all the things we have, and also on the hepatotox things. There was things that were interesting. So that's running, and it's showing that there is a success for us. Actually, we were able to make the data correct, clean enough, so that we can do things. So it's a big deal because it was listed as the main challenge at the beginning of the consortium, actually. Can we get the data out and use them? You can believe or not that we can model things. It's another discussion. But the first question was, can we get the data out? So, lesson learned. Took time, the IP and all that. I would claim that we are quite transparent on that one because the data are public in the consortium. By the way, it's not in public domain. We are trying to push some out, but it's not easy. But well, at least we are able to share. There is difficulties to get clean and usable data, of course, and that's linked really to the verbatim curation, the fact that there are so many ways of saying the same thing. You need to have good ontologies and code lists. I did not discuss here about that, but we created some that are going to the public domain also. It's an expert job and you need the right tools, so that's where I would advocate the Onto browser as a solution, but well, you can try it if you have time. And really it's paying off actually, it's a key enabler. Without doing that, you are going nowhere, nowhere. If you are not going to clean your data with experts, there is no way you will get something at the end. So it's a strong message. I know that everybody in the room is aware because we are all dealing with that kind of things. But well, you know, that's the kind of message you have to give to the management, of course, of this project, but also to the European community. When you spend 6 years to get all this data in, well, you expect people to say, yeah, well, that's really great. And what you hear is 6 years. So much, what did you do? Well, so you have to explain really that biology is hard, and also the data we have are not so easy to deal with. So I want to thank all the Work Package 2 members, specifically on the IMI-eTOX partners. That's a lot of people. And I will just advertise that we have a lot of things in there, including open source tools for modeling, beyond to browser, and other things like that. And it took me 15 minutes and 50 seconds, I'm late, sorry.